Hello, and welcome to Bear Power Solutions AC Voltage Input Panel presentation for Grantham University's Capstone, narrated by Cody Johnson. Looking at values arising from the substation level, we have power distribution and power transmission that encounters very high voltages. And the question arises, how do we turn these high, unusable voltages into something we can read by a simple computer, embedded controller, or just a simple meter? Taking a look at high voltage measurement, we want to take the voltages that are produced by the transformer, both sides, into something that's easily readable and something that we can view at a digital logic level. Some main points that we wanted to aim for during the process of this project were we want to make sure that it was affordable, so it had to be a very low cost product, that it was easily reproducible. Parts found could be purchased easily from your local Radio Shack or off the store, or quickly and readily available from DigiKey. It had to be a minimal footprint. We didn't want some large device going into the substation and taking up lots of space. It also needed to have a fast scan cycle. We wanted to make sure that we could read this data over and over very quickly, so making sure it was a speedy digital circuit. And then again, accuracy. We wanted to make sure that the value coming across was going to be something of in the order of a 16-bit value or an 8-bit value, to where the accuracy could be much higher than something a lot more integer based. The way in which this is normally done is you take a potential transformer, and essentially what that does is, through turns, lowers the magnitude of the voltage coming off of the transformer into something that you can scale. So it takes the high voltage and converts it down to something that's much smaller and much more readable. The purpose of this circuit is to take that high 0 to 10 volts AC and essentially minimize it into something that's usable in a digital logic circuit that we could sample over and over, find the RMS value of, and voila, we have our high transmission voltage into something that's easily readable and scaled down to at the computer. We have our 5 volts input from the potential transformer. Through the simulation, we can see that we've taken our 5 volt source and we've converted it down to 2.03 volts through a series of op amps. Here we have our constructed circuit. So this is the physical circuit that was created based upon that model. The parts were purchased and everything was assembled. Here we can see that supplying the 5.2 volts at the input side produces a output voltage of around 2.2 volts AC. From then, this value could be taken into an embedded computer, could be transferred out to a simple analog to digital circuit. Each one of those samples, we would find the RMS value as we sample it over time, because again, it is still an AC value. And then this value could be displayed back on the screen to a display in any of those forms. Lessons learned by this project. If I had to do it again, I would definitely use some sort of embedded case for the installation, just to make it a little bit cleaner to install. I could have increased the gain a little bit on the final resistor in order to give myself a larger voltage swing, so that I could maybe measure higher voltages than I really needed to, for the case of fault currents and things like that. And the biggest thing that was probably the most struggle was I would use 22 gauge solid wire instead of the stranded wire that I had purchased, because it's just a pain in the butt and it starts fraying. Overall, I think the project was a success, and the circuit certainly fell into all the parameters, and I think met the expectations of the project. Thank you.